K2-141b sits 200 light-years away, locked in a death grip with its star. This planet spins slowly, so one side faces its sun while the other remains in eternal darkness. The day side reaches temperatures of 3,000 degrees Celsius, over 5,400 degrees Fahrenheit, hot enough to turn solid rock into vapor. Here's the terrifying part. The extreme heat on the day side doesn't just melt rocks, it vaporizes them into gas. These vapors rise into the atmosphere and form clouds, like water vapor clouds on Earth, but containing vaporized minerals including silicon dioxide, sodium, potassium, and iron. Supersonic winds at 1.75 kilometers per second, over 3,900 miles per hour, carry mineral vapor clouds from the scorching day side to the frozen night side, where temperatures drop to minus 200 degrees Celsius. The cold causes vapors to condense and solidify, creating a deadly precipitation of molten rock droplets that fall like rain. This isn't ordinary rain. Imagine droplets of liquid lava, heated to thousands of degrees, pelting the surface at high speeds. The planet has a mineral weather cycle. Rocks evaporate on one side, travel as vapor through the atmosphere, then rain down as molten rock on the other. Over time, this continually reshapes the surface, creating an ever-changing hellscape of mineral precipitation. 750 light-years away orbits TRES-2b, a planet that absorbs light like a cosmic black hole. This gas giant reflects less than 1% of the starlight that hits it, making it darker than coal, darker than charcoal, darker than any known planet or moon in the universe. Most planets reflect at least some light. Earth reflects about 30%, Venus reflects 65%. Even our own moon reflects 12% of the sunlight that strikes it, but this planet breaks this fundamental rule. Its atmosphere contains chemicals that act like cosmic paint, absorbing nearly every photon that touches the planet's surface. The planet orbits incredibly close to its star, just 0.03556 astronomical units away, completing one orbit in only 2.47 days. Despite receiving massive amounts of stellar radiation, the planet appears as a dark void against space, visible only by the faint red glow of its superheated atmosphere, reaching 1,200 degrees Celsius. Scientists believe the planet's atmosphere contains gaseous sodium, potassium, and titanium oxide, compounds that absorb visible light across most wavelengths. The titanium oxide acts particularly effectively as a light absorber, creating an atmosphere that functions like a stellar light trap. The planet has essentially become a cosmic anomaly, a world that devours light instead of reflecting it. HD 189733b appears deceptively beautiful from a distance, a brilliant blue marble, resembling Earth. However, this similarity ends when examining its atmosphere. Its blue color results from silicate particles suspended in the atmosphere, not oceans or sky. The planet orbits very close to its star, heating its atmosphere to about 1,000 degrees Celsius on the day side. At these temperatures, silicate compounds, materials like glass and quartz, remain suspended as microscopic particles. These particles scatter blue light more effectively than other wavelengths, giving the planet its Earth-like appearance. Strong atmospheric winds, reaching speeds of up to 5,400 miles per hour, 7 times the speed of sound, carry the silicate particles across the planet. When atmospheric conditions change, these particles condense into solid glass fragments ranging from dust to larger crystals. Driven by extreme winds, they fall as glass rain at thousands of miles per hour, creating a planetary sandblaster. This continuous glass storm, fueled by extreme temperature gradients and constant stellar heating, results in perpetual precipitation of glass fragments, unlike Earth's weather with calm periods. WASP-12b orbits so close to its star that stellar gravity is tearing the planet apart piece by piece. It completes an orbit in just 1.1 Earth days at only 0.0229 astronomical units, roughly 1/40th the distance from Earth to the Sun. The proximity subjects the planet to massive tidal forces, millions of times stronger than those caused by Earth's moon. These forces stretch the planet from a sphere into an elongated egg shape, with significant diameter variation between its star-facing side and outer edge. The star's gravity actively strips away atmospheric material, which reaches temperatures over 2,500 degrees Celsius. This heats and ionizes atmospheric gases, forming a vast comet-like tail streaming away toward the star. Current measurements indicate the planet loses about 189 billion tons of material annually. Its orbital decay spirals it closer to the star, speeding up material loss. Astronomers estimate it will be consumed within 10 million years. A brief cosmic moment. This creates a feedback loop. As the planet loses mass, its gravitational hold weakens, making it easier to strip away more material. Closer proximity intensifies tidal forces and increases temperatures, accelerating atmospheric loss. WASP-12b offers a real-time glimpse of planetary destruction through gravitational forces. Kepler 70b orbits closer to its star than any other known planet, just 0.006 astronomical units away, roughly 1/60th the distance between Mercury and the Sun. This proximity creates surface temperatures reaching 7,000 degrees Celsius, hotter than the Sun's photosphere at about 5,500 degrees Celsius. The planet is the remnant core of a former gas giant. When its star became a red giant, the expanding atmosphere engulfed the planet, stripping away its gaseous layers and leaving behind only a dense rocky and metallic core. Kepler 70b completes an orbit in just 5.76 hours, making it one of the shortest known orbital periods. Its gravitational forces are so intense that it's tidally locked, with one side constantly facing the star. The star-facing side glows white-hot, while the night side remains around 3,000 degrees Celsius due to internal heat circulation. The surface likely consists of molten rock and vaporized metals like silicon and iron. The extreme heat prevents solid surface features. The entire planet functions as a molten ball of superheated rock and vapor. Stellar radiation continuously strips away material, and Kepler 70b is slowly evaporating, losing mass as its surface materials are ionized and blown away by stellar wind. The planet is in a constant state of destruction, with its surface boiling into space. PSO J318.5-22 floats alone in interstellar space without any star to orbit. This rogue planet, located 80 light years from Earth, was ejected from its original solar system and now wanders through the galaxy in eternal darkness and isolation. Despite having no stellar heating, the planet glows with infrared radiation from its own internal heat. This planet has a mass 6 times greater than Jupiter, making it potentially a brown dwarf, an object too small to sustain nuclear fusion like a star, but too large to be classified as a traditional planet. The planet's internal heat comes from gravitational compression and radioactive decay within its core. Weather systems exist on this isolated world in complete darkness, illuminated only by the planet's own infrared glow and occasional lightning flashes. The planet's magnetic field, generated by its rotating metallic core, creates auroras as it interacts with charged particles from interstellar space. These auroras provide the only external light source on the planet's surface, creating ghostly light displays across a world that never experiences sunrise or sunset. This planet demonstrates planetary survival in the most extreme isolation possible. Cut off from any energy source except its own internal heat, the planet continues to maintain active geology, weather systems, and magnetic field generation while drifting through the void between stars. WASP-121b exists in such extreme conditions that metals exist as vapor in its atmosphere and rain down as liquid droplets on its surface. This ultra-hot Jupiter maintains dayside temperatures exceeding 2,500 degrees Celsius, hot enough to keep iron, magnesium, and chromium in gaseous form high in the atmosphere. The planet orbits so close to its star that it completes one orbit in just 1.27 days. Tidal forces from this proximity have locked the planet so that one hemisphere always faces the star, while the other remains in permanent darkness. The temperature difference between these hemispheres creates the most extreme weather systems known to exist on any world. On the day side, intense stellar radiation heats the atmosphere until heavy metals vaporize and rise into the upper atmospheric layers. Iron, magnesium, vanadium, and chromium exist as metallic vapor clouds that circulate through the planet's atmosphere. Powerful atmospheric circulation carries the metallic vapors from the scorching day side toward the cooler night side, where temperatures drop enough for the metals to condense back into liquid form. This creates precipitation of liquid metal droplets, essentially rain made of molten iron and other metals, falling from the sky at terminal velocity. The planet's extreme heating also creates conditions where water vapor in the upper atmosphere breaks apart into hydrogen and oxygen atoms. The hydrogen escapes into space while the oxygen combines with metals in the atmosphere, creating metal oxide compounds that contribute to the exotic atmospheric chemistry. Extreme pressures and temperatures might also cause carbon to crystallize into diamonds or aluminum oxide to form ruby and sapphire crystals that fall as precious stone rain. The planet represents a cosmic jewelry factory where extreme conditions create valuable materials through atmospheric processes. Kepler 36b and Kepler 36c exist in one of the most dynamically unstable planetary configurations ever discovered. These two worlds orbit the same star, approaching each other every 97 days, creating conditions that threaten to destroy both planets. At their closest, the planets pass within 1.2 million miles, only 5 times the distance between Earth and our moon. For their size, this is an extremely dangerous proximity. When Earth's moon passes overhead, it causes small tidal bulges. These two planets create massive tidal forces that deform their entire structures. Kepler-36b, the inner planet is rocky with 4 times Earth's mass. Kepler-36c is a gas giant with 8 times Earth's mass, but lower density due to its gaseous composition. During close encounters, the gas giant's greater mass exerts strong gravitational pull on the rocky planet, stretching and compressing it. The gravitational interactions cause massive earthquakes on both worlds during each encounter. On the rocky planet, these trigger volcanic eruptions and landslides on a scale far beyond Earth's geological activity. Its surface reshapes every 3 months as the gravitational stress repeats. The gas giant also undergoes disruption. During close approaches, its atmosphere gets pulled toward the rocky planet, creating atmospheric tides. Clouds and gas streams stretch between the worlds, forming temporary bridges before being torn apart by orbital motion. This orbital configuration is inherently unstable. Computer simulations suggest gravitational perturbations will eventually cause the planets to collide or eject one of them. They exist in a cosmic countdown with their destructive dance destined to end in catastrophe within a few million years. These terrifying worlds remind us that the universe is far stranger and more hostile than we ever imagined, with planets that defy every rule we thought we knew about how worlds should behave. From raining glass and liquid metal to backwards orbits and stellar cannibalism, these cosmic nightmares prove that reality is often more incredible than fiction. If you enjoyed discovering these impossible planets that break the laws of physics, make sure to subscribe for more mind-bending space content that will completely change how you see the universe. And thanks for watching.